It is called general principle and processes of isolation of elements. General principle and processes of isolation of elements. In brief, we can say extraction of elements. Okay. See, in this planet, whatever thing that we get, maximum is from the surface of the earth. Of course, from atmosphere you get some gaseous substances, but the most of the thing that we get it from the surface of the earth. Okay, the surface of the earth is being covered with water or soil. Okay, soil may be in the form of plains, hills. Okay, then deep gorges, canyons. But my question is, what is soil? What makes soils to be found in the form of clay? We get it in the form of sand. We get it in the form of pebbles, stones, and boulders. All these substances are there, are chemical substances. Okay, all these substances are chemical substances. So they are made of chemicals. All right. So now in this art, we get the earth's surface is being covered with generally two types of substances. One with the inorganic substance and others are in the form of organic substances. Organic substances, how do you get it? Organic substances we get it from the plants. It may be the leaves, flowers, seeds, or suppose the plant after death is the decomposed portion of the plant. So these are the organic substances. The rest of the substances are inorganic substances. Okay, rest of the substances are inorganic substances. Now, in this, as I told you, these are being made of the chemical substances. In these substances, you may get some of them in the free state. Free state means what? Uncombined state. And we technically call them as native state. That is, there are some elements which are not that reactive, exist and found free in the nature, but these type of elements are very, very few. It may be in the form of platinum, gold, silver, sulfur, and some extremely non-reactive substances like nitrogen, oxygen, that we get it in the free state along with the inert gases in the atmosphere. So these are called, they exist in the native state. Sometimes somewhere, some part of the world, people have even discovered mercury also in the native state. Otherwise, most of them are found in the combined state. Combined state, that metals and the non-metals which are extremely reactive, metals like group 1, group 2, group 3, and most of the metals, and the non-metals from the group 17 halogen, they never exist in the free state in the nature. So that we get it in the form of combined state or in the form of compounds. Okay. Now in this chapter, we'll come across some of the typical terms which are being used. These are, first of all, we call it is a mineral. Minerals. The naturally occurring chemical substances. Sorry. Substances which are present either in native state or combined state are called minerals. See, in CBSE definitions often is not being asked, but those who are from MBOS, please write down this definition. In MBOS, definitions are also being asked. Then we'll come across the term called ore. The minerals from which the metals or non-metals can be obtained economically and conveniently let me remove here obtained without extract are called ores. Write it, then I'll explain. What is the meaning of this? Can be extracted economically and conveniently. Suppose, say, you got a huge gold reserve on the seabed. So it is difficult for us to get it from there because you have to send the divers. And moreover, even if you suppose you can go and extract it, your cost of extraction will be very high because you have to divide so many things. So it is difficult. So in that case, even if it is rich, we it is worthy to be called as ore, but we cannot because it is inconvenient for us and it is economically not viable. So please remember one thing, it's a very famous saying. We call it all ores are minerals, but all minerals are not ore. It's a very famous saying. Why you know? Why all ores are mineral? Because the ores are chemical compounds. So because of that, they are mineral. But why all minerals are not ores? But suppose you have got a mineral in which you may find only 1 or 2% of gold is there, 1-2% of silver is there. The rest are all junk. To separate 1 or 2% of gold and silver from their amount of money that you have to spend, in that case, gold is already costly, it will be very, very costly. So it will not be economically viable. Okay? It minerals can be ores only when the location is favorable for us. We have to spend less amount of money, and that mineral should be rich in specific metal. It should be more. It should be 8, 9, 10, 20% like that. Only then we find it's economically viable. So it's a very famous thing. All ores are minerals. Why all ores are minerals? Because they are all chemical substances. But all minerals are not ore because if it is inconvenient, if it is not economic, and moreover, if the percentage of the certain metal in that ore is very, very less. Okay. Now, so moment we say that one means if a mineral contains certain metals which is rich, so it is not 100%. That metal may be present or element may be present in 7, 10, at best we are very lucky 20%. Then what are the rest 80%? The rest are 80% are the undesirable, are the substances. So these are impurities. Okay. So for that we use a word called gangue. Yeah. So what is the gangue? Gangue is a matrix of the ore. What is matrix? Matrix is the surrounding. Okay. So gangues are the matrix of the ore which consists of are the undesirable substance. Yeah, consists of are the undesirable substances. So these are called gangue. Okay. So let us start. Today I'll tell you some, I'll tell it not in the form of chemistry. Let us start from the origin of the earth or the planet. See, there are different types of theories are there. Some are mythological. Okay, most of them are mythological, but we know the most scientific theory given in the formation of the planets is that we know that all the planets in our solar system has originated from sun, and that has happened by the Big Bang theory proposed by Stephen Hawking. That is, there was an explosion in the sun, and by that way, some portion of the sun is being thrown out, and depending upon their mass and the velocity, they have traveled different distances from the sun, and they are moving around the sun because of the gravitational force. So it has started from there. As in the sun, oxygen is not there. Okay, the flare is only because of the thermonuclear explosion, which is happening because of the combination of hydrogen atom, eh, and later on again splitting into hydrogen atom, leading to the constant evolution of different types of electromagnetic radiations. We call them as cosmic ray. So when this planet has come out, most of these elements were found in the free state. They're in the native state. And very interestingly, initially only 4 to 5 elements were present. Later on, because of the constant process of the transmutation and transmutation, okay, fission and sorry, not transmutation, fission and fusion, many other planets got formed. Initially, in the atmosphere of Earth, we had very high percentage of oxygen and hydrogen. So the surface of the Earth was burning for several thousand years. It was burning. Please remember that our atmosphere contains only 20% of oxygen, and it is a blessing in disguise. 76% nitrogen, it is chemically inert because of nitrogen triple bond, which I'll discuss to you when I go to P block. It is a blessing in disguise. If the oxygen would have been more, if the ratio would have been reversed, the nitrogen 20% or oxygen is 70%, nothing would have existed on the surface of the earth because everything would have been burning. So our atmosphere is, nitrogen has diluted our atmosphere to a bearable limit of oxygen to 20 to 22%. Of course, these days, the ambient condition of our atmosphere is being disturbed by the constant evolution of carbon dioxide that leads to a catastrophic on the surface earth atmosphere that we know, all of you know. So when this surface of the earth was burning, the elements got combined with the oxygen. Hydrogen got combined with the oxygen, and later on when it got cooled, it has come down in the form of rain and filled up our lower level of the earth with water. And those oxides which are being formed by the burning of metal, they get converted in the form of soil. And due to millions and millions years of this thing has taken, it has solidified into very hard mass, and by constant force of pressure and temperature, they have become extremely hard. Okay, till we know the core of our earth still is being filled with various types of molten elements, and one of them is iron. So this is the way the surface got coated with the oxides of the different elements. These oxides later on reacted with different types of gaseous substance and acids created by them, and they form different salts. Okay, so the ore can be classified into different categories here on the basis of their composition. Interestingly, somehow these things have been missing from our textbook. Okay, so the various types of ores that we get it in the nature. First one is, as I told you, these are the native ore. native ore where you find these metals, they exist in free state. Only those metals which are chemically inert, okay, whose reduction potential is very high positive value, means they do not like to have a tendency to lose electron. They generally exist in the form of uh, pure state, platinum, gold, silver. So they are sometimes found in the surface of the earth crust, but that abundance also is very, very less. You can get in the form native ore. Then you can, this is extremely abundant, the oxide ores. Okay. I will not cite oxide, I will write oxidized ore. Why? Why I call it oxidized ore? Because I'm not going to write the equation now. This is not a part of your syllabus, but you should know. Oxidized ore means what? These elements initially got converted into, I'll write Lm. So it has combined with oxygen, say it has formed oxides. So if they are stable, you'll find it in the form of oxides. It may happen these elements have combined with water, so you may get them in the form of hydroxides. Various metals are found in the form of hydroxides. It may happen this they got combined with the carbon dioxide. We have plenty of elements which you find in the form of carbonates. We get in the form of bicarbonates. So all together, they are called oxidized. Then you can get it in the form of sulfide. Sulfide ores are generally found near dead or active volcanoes because from volcano there is a huge evolution of hydrogen sulfide and sulfur dioxide takes place. Okay, in the molten lava also contains a lot of molten sulfur. So you can get it in the form of sulfides. You can get it in the form of sulfates. You can get it in the form of sulfides. So various this type of ores are available. Okay. So you can also get in the form of this ore is very abundant. It's called silicate ore. Silicate. See, this is the substance which is covering almost larger portion of the earth crust. Silicate ores are, first of all, silicon dioxide is sand. Clay is silicates. Okay, so you can get it in the form of silicates. Okay, then you can get it in the form of phosphates. Phosphate ores are not that abundant, but still you can get phosphate. Then you can have halide ores. Halide ores. Okay. Then you can get here complex ore. What is complex ore? Complex ore are the combination of two or more than two ores. So they form a cluster and form a complex type of substances. So all these things that you are going to get it. I'll rub it, you need not write it, okay? Because I'll be sending you the notes, so you will know from there. So why you have to study this process? Initial formation of the ores was a spontaneous process. Now, dear, you know thermodynamics. You know thermodynamics. The process was spontaneous because of that element got converted to oxides. Then they combined, instead of oxygen, they might have combined with sulfur. Okay, then you get sulfide ores. So from oxides ore, we know that from oxides ore can get converted into hydroxides, carbonates, bicarbonates. If the oxides ore reacted with the acids, it can get converted into metal halides. If it combines with the nitric acid, because you know rainwater contains nitric acid, it can be converted into nitrate ore. Okay, so all this process was spontaneous. Nobody requested them. In this chapter, the thing which you have to learn that you have to reverse the process. We want to get back the metal from the ore. Metal to metal ores were spontaneous. Now, from metal ore, we want to get with the metal. So the process is not spontaneous. And I will tell you a small story. You heard about Akbar, and also you know in his courtyard, one very intelligent person was there who is being generally labeled as a jester, court jester is Birbal. But actually, Birbal was a very, very famous soldier and he has led army in several battles to fight on behalf of Akbar and he owned. Thing is that he was very intelligent. So Birbal once, because of some his personal reason, he came little late to the court and the king got, emperor got extremely angry with him. He told, why you are so late when everybody has come? What specialty you have? Huh? That you can have one come late. He told me, sir, I came late only because of my younger son. Then he told, there are so many persons are there in your house, huh? And you are a noble person. There's no dearth of person in your house. Then why you have to give the excuse of somebody? Sir, please hear my story first. Then only you tell. Okay. Then he told, what is the story? Yes, sir, morning my son told that he want to eat sugar cane. Then I asked my servant to bring sugar cane, and then he told that you only have to cut it. So he removed the skin of the sugar cane and he cut it into small piece. Then after some time, he suddenly changed his mind. He told me, no, I want to eat the whole sugar cane. People again asked his servant to bring. He bought a fresh one. He said, no, I don't want that fresh one. You convert that sugar, that pieces into sugar, original sugar. I told him it is not possible. He did not agree and start crying. So, except me, nobody can console him. Because of that, I got angry. Then Birbal Akbar could understand the problem. Okay. So here also the story is saying sugar cane has become converted into sugar piece. Now, can you join those sugar cane pieces into visible? No. Here also the story is saying we have to convert the metal oxides into metal. Don't worry. We know thermodynamics. Initially, the people had done the whole process. Initially, people have gone for trial and error method. But after the the adoption of the thermodynamics, things have become very, very clear to us. That I'll tell you later on how the thermodynamics can be applied on it. So now, say you want to get some metal and you want to start a metallurgical industry. So before that, let us try to know what is called metallurgy. So metallurgy is the scientific process of extraction of metal, pure metal from the ore. First of all, that is the definition of metallurgy. So it is the scientific process used for the extraction of pure metal from ores. All right. So you have to get this, first of all, you have to get the ore. So how you get the ore? Because you, it's not like that you have dreamt about it and you someone has told you, please go to uh, uh, border of Bangladesh in this Warjantia site, and in that mountain you'll find two three big stones are there. After you remove that big stone. Below that, you will get the ore of manganese. Positive. Okay, you will get the ore of manganese. It is not possible. So never happened like this. All right. So for that, a survey has to be done. This survey is very strenuous and time taking. Almost in all country, it is survey is being done by the government. In Shillong, we have the northeastern headquarter of such survey. We call it Geological Survey of India. Geological Survey of India. All right. So they go on foot for the entire state of Meghalaya. So that type of survey they have done in all the states of our country. Many places they might be that they did not visit because of some inconveniences or for the terrain, or sometimes some places some hostility always take place also, or resistance is there from the local people. So they have collected the stone, pebble, soil and everything, and they bring it to the laboratory. In their laboratory they go for physical study, they go for chemical study, they have a full-fledged chemistry laboratory, and from there they try to dissolve the metal, because metal present that in the form of compounds only. So try to dissolve in acids, bases or any other solvents, and they try to estimate it by different chemical techniques. These days sophisticated instruments are being used, who even can find the presence of an element in the ppm level. These are called atomic absorption spectra. So, and they will level it and they will inform to the government. They will say such and such area in the district, the, that we find that is a rich uh, source of manganese is there, magnesium is there, aluminum is there, all types of things will be they'll notify. Then after that, government will decide whether they will do by themselves or they will hand over to the private companies. Initially, in our country, all this metallurgical extraction was being done by government, but nowadays they are many places they are handing over to the private parties. So what they will do? Now they do not have the problem of locating the wood because they are already being told and the area is being located. Say it may be that 100 square kilometer area is rich in this thing. Just like in Meghalaya, huge places there, we have a huge stock of limestone. That was being done, survey was done by British. Even Geological Survey of India, that concern also being started by British. So it will be leased out to them. Yes, because this ore formation have started millions of years ago, so they are found in the form of hard rock. So the place is being selected. Now the question is whether they will go open cast mining or they will go for the deep mining. That depends upon at their convenience. So they will bring it out. They generally find it out in the big lumps of stones because they have broken it. And after that, these stones are not being directly taken to the industry. So they are being crushed at the same site too, because most of the industries are present in the populated area. So they are being crushed and made into powder in that spot only to avoid noise pollution as well as air pollution. So what is the first step involved in the extraction? The first step involved in the extraction is the crushing and grinding of ores. So they are initially the big boulders are made into smaller pieces by the jaw crushers. You might have seen on Shillong Guwahati Road was being made very recently, that 4 lane. You have seen this type of jaw crushers are being used to break the big stones on the highway, so that they can be used for making roads. After this, they are being broken down into smaller. Then after that, again they are being converted into very small piece or powder in the form of uh, ball mill or stump mill. Well, they will find constantly they will pound on this on the stones, and they will convert it into powder or small pieces. Okay, so this process is known as pulverization. This process is known as pulverization. Okay, next second step onwards now. So stage is called concentration. Okay, or benefaction, or dressing of yours. Then these oats are being sent again to the chemistry laboratory to find out that how much amount of the substance which contains our desired metal or element. So they will find out the percentage, and rest of them are the undesirable substances. So they will try to find out the composition of the ore, how much is there the useful substance, and how much are there useless substances. Useless substances or undesirable substances, we call them as gangue. So you have to concentrate the ore. That is, you have to remove the impurities. A full-fledged physical and chemical study is done on the ore and the impurities. They will try to find out what is the weight of the impurity, what is the density of the impurity, in which thing they are soluble, and all these things. Okay. So on the basis of that, they decide what are the techniques should be used for the purification or the benefaction of ore, which you call it dressing. So for that, physical process methods are being used, and the chemical methods are also being used. Among the physical method, the physical method, there are different techniques are there. Okay. So first one you call it gravity separation, or levitation. This word is not being mentioned in the textbook. Levitation or hydraulic washing. Hydraulic washing. Now, I believe most of you in this group know how to cook rice. Okay, maybe the some of you are uh, you have not done it by yourself, but you have seen how it is being done. So when you go for cooking of rice, what you do? First, you take the amount of the rice that you want to cook in a pot, and to that we add water. Okay. So when you add water, you find along with the rice, so many other dirt may be present. which are lighter than the rice. So moment you put water in the rice and you try to move your hand across, you find the lightest substances starts floating. Then you drain out the water and you do it for few times until unless the water becomes clean. Here also you do the same thing. In gravity separation, please remember, odes are heavier than the impurity. Odes are heavier than the impurity. So, in that case, what you do? We allow the we take this type of tilted table along with some wooden beam. My drawing is very bad. Okay, it is like this. It is like this. So there it will be very long one, and this here you will find the powdered oil is kept, and the water flows from here, and the table go on shaking. This table is called will flay table. Will flay. Now what will happen? All the lighter articles will cross over this barrier and flow out, and the heavier substances will get stuck in this before this barrier. Okay, so that way you can remove the lighter impurities. Okay, see, this is one of the way by which we purify we try to extract gold. The density of gold is 19.6. 19.6. That is, if you have taken 100 ml of gold, it is going to weigh 196 gram. So golds are being separated by this process. I do not know whether you have observed this thing. If you wish, you can see from the YouTube. They'll show you how people are extracting gold. Only they take the sand and everything, put plenty of water and go and shaking, and by that you will find the gold particles do not overflow. It remains at the bottom. Okay, so this process is being done where you find the odes are heavier than the impurity. But in some ore you find the impurities are heavier than the ore. So in that case, what happened? The powder odes are being taken in huge tank and fitted with a propeller. Okay, and plenty of holes are there in the propeller. And the ore is being fed here through conveyor belt. It comes and is filled with water. Okay, filled with water, and continuous flow of water will be there. And this propeller will continuously flow, and they will, through this propeller, they will send air under pressure. So what will happen? All the air bubbles will come, and along with the bubbles, the lighter ore will come to the top, and it will overflow to another tank which is kept at the bottom. So time to time they will stop, allow this water to settle. This also will settle. From there they will get ore, and this sand and all other useless things which are there, they are being taken out and they are being taken as a debris. So this, both the processes are there. One where the ores are heavier than the uh, impurities. In that case, we use will flay table, and where The ores are lighter than the impurity. In this case, we adopt this process of purification. In this chapter, I have to talk more, but it's very easy chapter. Second one is called magnetic separation. Magnetic separation we hardly use. Why? In that case, either the ore or the impurities should have magnetic property. So in that case, what happens? The powder ore is being rolled over a conveyor belt. Okay, so by this conveyor belt, the powder ore will come. And in this case, you will find one of the wheel is magnetic. So this is the magnetic wheel. Magnetic wheel. So this conveyor belt constantly moving. So when it comes here, you will find the substance, whether imagine that it is an ore of iron, Fe3O4, we call it magnetite. I didn't solid state, I told you. So this is magnetic in nature, and its impurities are sand, clay, humus, that is the leaves and everything. They are not magnetic in nature. Moment the conveyor belt will move, all the non-magnetic substance will fall here, and the ores will be carried out because it is a strong magnet. So when they will come here, you will find then the magnetic substances are falling here. See, such beautifully the two type of substances are being separated. So when you go for hematite, sort of hematite, magnetite, you go for this type of magnetic separation. But in some cases, we find impurities are magnetic in nature. That happens in case of the tin ore. Tin ore is SnO2. So there we find we have iron chromate, iron tungstate. This is a very, very important. Let's see. It's not that all impurity you have to throw it. Many impurities contain very, very costly elements. Okay, but it's as because its abundance is less, we think it is impurity. So when you go for the tin ore, we find the iron tungstate, which is magnetic in nature. In that case, what is going to happen? That you will find that impurity will be here, iron tungstate which is magnetic, and the tin ore will be here, which is found to be non-magnetic. Okay. Now we'll come to a very important process. Actually, for examination purpose, we call it froth flotation process. Froth flotation process based upon a principle. So, what is the principle behind this one? The method is based on the principle of degree of wettability. Excuse me. is the meaning of wettability? How quickly it can get wet or absorb liquid. Degree of wettability of the ore and GAN to water and well. If you sprinkle there water and well, you will find that some of them can absorb well faster than the water. And in that case, other will be reversed. Other one is going to take, absorb water much before the well. Now, let me take a simple thing which you can try at home. You take two pieces of paper. In one piece, you put few drops of any of your cooking medium or well, and you try to spread it so that entire that portion of the paper get wet in the well. And now take the other one also where you did not put both of them on water. What will observe after some time? You will find the paper which is being coated to the well, it did not get wet and it floats on water. The other paper, it will absorb water and after that it become heavy and will sink to the bottom. So this is the technique. We separate this process. This principle is important both for CPS and MBOS. They will ask you what is the principle behind the froth flotation process. Please write the principle.
Done, sir.
Okay. Okay, now I'll show you. So it is a huge tank fitted with a propeller. It is a perforated propeller. And it contains water. And then to that through conveyor belt, we put the ore. Ore is there. So now, to that what you did to, we add here some well which are cheaper. Pine well. See, you find in Meghalaya is very, not, I should not say entire Meghalaya. This Khachi and Jointia hills has plenty of pine trees. And you might have seen, suppose if you, there is a scratch in the bark or if you cut it, you'll find after sometimes some a very sticky substance which comes out, which you call as pine resin. Pine resin, if you distill, you'll get well. Pine oil is being used as a medicine also. Okay? These are being used in in the pin balm or eucalyptus. Eucalyptus. We do not grow so much eucalyptus, but if you suppose if you go to Australia, New Zealand, in all these places, they are famous for eucalyptus. So they can go get the eucalyptus well. Both these pineweed and eucalyptus or well are used in pin balm. So it is being put there. So this is the valley there. Okay. So now you send highly compressed air through that. What will happen now? It will come in the form of bubbles. Bubble will push both the impurity and the more on the top. When it goes to the top, the oil immediately absorbs the oil. A lot of foam will be generated. Okay, but mind it, you might have I should not say might. Every one of you use it. When you try to wash your cloth in detergents, you put detergents in bucket or you put detergent in the water, then you stir it. Lot of foam comes. Sometimes it overflows. But after 2-3 minutes, you'll find that the foam dies down. In this case, what they do? They put the stabilizers so that the foam should not immediately die. Okay? So they use stabilizers in the form of aniline or xanthate. That is, the foam is not going to die so fast. So what is going to happen now? When there will be more and more foam, then it will roll down and it will be collected on the tank below. Then after some time, suppose foam is not going to last for whole life, maybe say after half an hour or 1 hour, you will find all the foam will settle and you will get the ocean and impurities will remain. So it is found that froth flotation process is used for the concentration of sulfide ore. Concentration of sulfide ore. This is important point to be noted. Froth flotation process is used for sulfide. So in that case, we use pine well or eucalyptus well. And to stabilize the foam, we use foam stabilizers in the form of aniline xanthate. All right? We don't use both, either aniline or xanthate. Now, the problem happens. Suppose the ore contains 2 sulfides. Say the ore contains lead sulfide as well as zinc sulfide. Because generally you find that similar types of ores are always found in the nearby area. So if you follow this process, now this is going to contain both lead sulfide and zinc sulfide. So in that case, what should we do? So we go for preferential froth formation. That is, I have to suppress one. But in this condition, any sulfide ore is going to froth. Okay, so I cannot verbally request that you please don't come. So what we do, we can take the help of depression. So we take the help of depression. Okay, depression. So in this specific lead sulfide and zinc sulfide combination, we take the help of sodium. We take the help of sodium cyanide. See here, Sodium sulfide, sodium cyanide does not react with lead sulfide, but it reacts with zinc cyanide. So zinc sulfide. It reacts with zinc sulfide to form a complex. So you will get here Na2Zn. Its name is sodium tetracyanidosincate. Now, say this is the ore of zinc. Sodium cyanide cannot go penetrate inside it, but outside you find there is a layer of formation of this. This compound absorbs water. So when you have taken both lead sulfide and zinc sulfide went to the top, but while going, because you have already put sodium cyanide here, zinc starts reacting and forming this one. So even if it goes, it absorbs water and sink down, only here you will find the lead sulfide is going to form the foam. So lead sulfide will be here, lead sulfide will be here, and zinc sulfide now in the new form is going to be present here. Now dear, after I separated lead sulfide, then should I throw this thing? Because zinc is one of the most essential thing that we require. Everywhere you require zinc. Okay, huge amount of zinc is required for galvanization to stop the process of rusting in the iron. All right, zinc is being used for making of this the soldering of this soldering we do for the joining of electrical equipment. So we cannot afford to lose zinc. So what should you do? Once this process is over, we'll try to regain the zinc there. So in that case, initially we use depression, then we want to get it back. So we use here activator. In your book, this is mentioned, but this is not being mentioned. Activator. So once everything goes out, okay, to that tank we use copper sulfate. So I'll write now here. See, the solution contains this sodium tetracyanide of zinc, sodium sulfide, and to that we have used copper sulfate. See, now what is going to happen here? You'll find it will give you zinc sulfide. It will give you Na2CuCN4, and you'll get here sodium sulfate. See, it has become now free. So after that, what we'll do? We'll again put here pine well or eucalyptus well. Again, you'll put aniline and xanthate, and we'll send air. The next batch of the foam which will come out, of froth which will come out, it will contain zinc sulfate. Please remember this one, activated as copper sulfate, though it is not there in your book, but it is useful for your entrance exam. So the note which I have written here, it is little more elaborate than from your textbook. So please go through the every line of the note. Okay, don't feel bored. I have written in detail because there cannot be any shortcut in your chemistry, which is being written in your textbook. It is very, very unwise. You should know everything. All right. All right. Now, these are the different types of physical processes. But there are some minerals which you cannot purify with the physical process. So when you cannot do it with the physical process, then we have no other alternative to go for process. But mind it, dear, in most of the cases, we still go for the physical process, because physical process, it may take little more time, but it is cost effective. In every production, huh, cost is the most important thing. If things are cheaper, people will buy. If things are costlier, people will not buy. See how many people can afford to buy gold? Very few people. But most of us, we go for buying the cheap metal like iron. Okay. So the next process we will go for the chemical process, and that is known as leaching. So leaching is a chemical process of purification of ores. What is the principle behind it? Principle is that it involves the treatment of the ore with a suitable reagent to make it soluble in water. I will not write it water. Make it soluble. So what is going to happen? Impurities will not be soluble. Ore will be soluble. So in that case, you can filter it. See, leaching process initially may be costly, but you can get 99% of the ore from there, because in physical process, a lot of things are being wasted. Okay. But here, theoretically, you are supposed to get each and every atom in the ionic form in pure state. While the impurities remain insoluble and are removed by filtration.
So I'm done writing.
Okay, now we'll do example. Purification of ore of aluminium. Okay, within bracket you write here bauxite. See, ores always derive the name from the local people because where it is available. They used to call that mud as this. Okay, bauxite. So what is bauxite? Bauxite is Al2O3 2H2. All right. It contains impurities, but we have sand. Plenty of sand is there. Please remember, India is the richest source of bauxite ore in the world. Okay. Then iron oxide, Fe2O3, and a very important impurity is there. That is called titanium dioxide. Titanium dioxide. Okay. So please remember this one. Even if you throw it as a impurity, remove its impurity, but from there we try to get derive titanium dioxide. Okay. Say, suppose you were coming from home, coming from market, and from your hand 20 rupees fell down on the, if I fell in the drain along with your earring. If 20 rupees fall in the drain, will you collect that dirty drain? Huh? We'll pick it up from there. Hello,
No,
no
sir.
reply. Hmm?
No, sir.
Even you are doing
No,
this.
sir.
But if your earring falls in the drain, what
So
will
we'll
you
pick
do?
it up.
Huh? You will pick it up. Same is the case here. This. So how do you do it? See here we will find bauxite ore is heated with a concentrated, you need not write, you will get the note. Concentrated solution of sodium hydroxide. They are around 45% sodium hydroxide you take by mass. Okay. At 473 Kelvin, 200 degrees Celsius, under 35 to 36 atmospheric pressure. Then what happens? See here. Alumina, that is bauxite, reacts with sodium hydroxide, is insoluble. React with sodium hydroxide and water to give you 473 Kelvin, 35 to 36 atm. You know how do you cook, boil it? It is just like our pressure cooker. We call it autoclave. It's big pressure cooker. Huh? Okay. and it gives you hydrated sodium metaluminate. Means actual formula of sodium aluminate is NaAlO2. Okay, as because in your textbook they have not given that formula, you will find in my note it is there. So it is, we call it hydrated sodium meta aluminate. It is water soluble. Water. Along with that, sodium hydroxide also reacts with sand to get Na2SiO3. We call it sodium silicate. Sodium silicate is soluble in water, and sodium silicate is another name. We call it water glass. Okay. Rest, the impurity of titanium dioxide and the iron oxide are not soluble. So we cool it down, the entire mixture, and we filter it. So titanium dioxide and iron oxide is being removed completely, 100% they are being removed. All right. After that, we take the filtrate. Okay. The filtrate is diluted with water to lower the pH. Why? Because the sodium hydroxide, high concentration sodium hydroxide is there, pH is very high. It is either diluted with water, and we continuously stir for 2-3 days. And to that we add some aluminum hydroxide as a for seedling. Then you'll find gradually from there insoluble aluminum hydroxide is precipitated, but these days it is not being done. Why? Because 3 days time in industry is a huge loss. So what it is being done? Do that, we lower the pH with the help of passing carbon dioxide, because we know aqueous solution of carbon dioxide is carbonic acid. So we pass carbon dioxide through that, and after stirring it for few hours, you will find a solid mass is being separated. Okay, but in this situation, that sodium silicate does not precipitate. Why do I write XH2O? Because it is wet. So this is being filtered. Is being filtered, and the filtrate can be discarded. From there you can isolate sodium silicate. Now this wet alumina, Al2O3 alumina, is being heated strongly around 1470 Kelvin. In electric furnace we heat it, and by that way what happens? All the water goes out, and here you get here, this goes out in the form of vapor. So you get here pure alumina. This is 99% pure. Okay, up to this much is enough for today. I shall discuss 2 more examples on next Tuesday. Not sorry, Saturday. Last Saturday somehow I don't know. I was doing some work for you only. I have finished doing all the problems of 4 chapters. So I was doing this problem, and because of that I forgot. Anyway, sorry, I missed one class. So I'll be sending this note to you. Bye. Good night.
Thank you, sir.
Welcome.
Bye, sir.
Bye bye.